Today's lesson is on how do we find probabilities of compound events. The first question, you play a game where you flip a coin and spin a spinner with 6 sections. 2 sections are red, 1 is blue, 1 is orange, 1 is black, and 1 is yellow. What is the probability of winning the game if you need a tails and a red? Take a second to copy down the question. Now, we need to find the probability of winning the game if I need a tails and a red. So the first thing I need to do is figure out my total possible outcomes. I need to see how many events there are. I'm flipping a coin and spinning a spinner. So I have my first event, which is the coin, and I have my second event, which is the spinner. For the coin, there are 2 events, 2 options, and for my spinner, there's 6. So I'm going to multiply those 2 numbers to get that there are 12 total possible outcomes. So I know my final answer, my probability, is going to be some number over 12 because there's 12 total possible outcomes. Now I have to determine how many outcomes there are that get a tails and a red. Whenever there are 2 possible events, the easiest thing to do is to create a table. I can have heads and a tails for my coin. Now I'm going to list the options for my spinner. 2 are red, so I can have a red and a red. 1 is blue, 1 is orange, 1 is black, and 1 is yellow. Now, this table is different than when I was creating tables to show all the possible outcomes. I don't need to show all the outcomes. The only outcomes I care about are the ones that have a tails and a red. So this whole section with heads, I don't care about them. I don't even have to fill them out. I can just look to see where I have a tails and a red. I'd have a tails and a red in this section and a tails and a red here. I wouldn't have a tails and a head anywhere else. So there's 2 possible outcomes. Now I always want to reduce my fractions. So 2 over 12, I can reduce that to 1 over 6. So the probability of winning the game if I need a tails and a red is 1 out of 6. The second question. The names of all students with perfect attendance are entered into a drawing to win 1 of 2 tickets to a baseball game. Angie, Mark, Phil, Carly, and Josie all have perfect attendance. What is the probability that Mark wins 1 of the tickets? Take a second to copy down the question. The question is asking the probability that Mark wins 1 of the tickets. And there are 1, 2, 3, 4, 5 people who have perfect attendance. So I need to first determine how many total outcomes there are. So I can have ticket 1 and I can have ticket 2. Now there's a key part in this problem. You can only win 1 of the 2 tickets. So for ticket 1, there are 5 total possible people that can win it. For ticket 2, however, once that first person is picked, that person cannot win the other ticket. So there are only 4 possible people that can win the next ticket. So 5 times 4 is 20. So there's a total of 20 outcomes. So I know my denominator is going to be 20. Now with this problem, since we have this option of not being able to win both tickets, a tree diagram is going to be best to list out all of our possibilities. So I'm going to create my tree diagram. My tree diagram, I'm going to start with Angie. Angie can win the first ticket. If Angie wins the first ticket, that means Mark can win the second, or Phil, or Carly, or Josie. Angie can't win the second ticket because she already won the first ticket. The next person who can win the first ticket is Mark. If Mark wins the first ticket, there's 4 options for the next one. It can be Angie, Phil, Carly, or Josie. The next person who can win the first ticket is Phil. If Phil wins the first ticket, then Angie can win the second, Mark can win the next, Mark can win the next, Carly can win it, or Josie can win the next. Carly could also win the first ticket. If Carly wins the first ticket, we could have Angie, Mark, Phil, or Josie win the second ticket. Josie is the last person who could possibly win the first ticket.
I'll be right back. I have the phone call.
If Josie wins the first ticket, then Angie can win it, Mark can win it, Phil can win it, or Carly can win the second ticket. Now, I need to find the probability that Mark wins one of the tickets. So I need to see everywhere I have Mark winning a ticket. I have one option here. I have 1, 2, 3, 4 options here. So I'm up to 5 total. There can be 6, 7, 8. Those are all the possibilities where Mark can win a ticket. So it'd be 8 out of 20. And I can reduce 8 out of 20 to 2 over 5. So there's a 2 out of 5 chance that Mark wins one of the tickets.